Hello everyone. In this video, I'm gonna talk about the Photon network architecture that I've set up for my project. And I initially was gonna talk about these, things I've been working on the, weekly update that I'm trying to do. But I've decided to make its own video because I think there's a lot of technical details that are valuable to know because I haven't been able to find a lot of these details online myself. So I thought, sharing these details might be helpful for someone else. And but before then, I just want to do a quick intro. So first of all, why Photon? I chose Photon because I believe it is the easiest one to get started with. Of course, it has its limitations. After a certain point, it's gonna be pricey for you, etc. But I think if you're just getting started, like me, and you just want to do a project yourself, and you know, I think it's the best option because they do a lot of the heavy lifting for you. And also, you might have seen this on their website, but it is free to use up to 20 players at once. And this sounds little. You might be thinking, "Oh man, when I make my game, I don't want to pay for the server." But according to their estimations, for 20 concurrent players, you need 20 times that amount as monthly players. I'm sorry, daily players, so 400, and 20 times that as your monthly players, so 8,000. So if you have 8,000 people playing your game monthly, you're probably making enough money to be able to run a Photon server anyways. So 20 CSUs is actually useful, especially if you're doing a smaller project. And a little bit about my project, what I'm trying to do is a game where there's a 3D map and there may or may not be blocks in each position, sort of like a Minecraft grid. And each player will have different types of bombs to destroy those blocks, or they can also place new blocks, and this will all be synced across all the players. And basically, when you fall down, you die, so you're trying to be the last one standing, sort of like Super Smash Bros. Um, and this means that, when I throw a bomb, the bomb should be thrown in each client. They should all be destroying the same blocks. When I place a block, that should be synced. I can leave the lobby, join back in. I should be able to join in the same map state, which means, if certain blocks have been destroyed or certain blocks have been created, that should be all synced up. Otherwise, it wouldn't really make sense. And so also, I am expecting this video to be a little bit longer than my usual ones. And I honestly initially thought about doing multiple shorter videos, and I was trying to like compartmentalize the ideas that I want to talk about, but then I realized the concepts are so connected that I think a single video will make the most sense. But I will still try to do some timestamps both in the video and in the description so that people can jump to the parts that they're interested in. But I think a single video will make the most sense. I also have one note about Photon, and that is the debugging can sometimes be hard because it's not like in Unity where if you make a mistake, say pass a top type of data that's not acceptable, it doesn't really say anything. Like it's not gonna be underlined in red. It's gonna work. Your game will compile, but it just won't work in game, obviously. So I highly suggest if you're struggling with anything related to Photon to, try to look in the forums, try to look at their documentation, look at like what types of data could you be passing, is that allowed, etc. Because I have been in that situation a lot of times. And these are the general concepts that I'm gonna talk about in this video. So first of all, the inherited classes, PUN and PUN callbacks, and then the imports that are useful, Photon.fun, .realtime, .utility scripts. Then I am gonna talk about the RPCs and the clients. So, what are RPCs? Why are they useful? What kind of RPCs can you send? So there's different types of targets you can send. So also here I'm gonna talk about what's the master client and how is that significant for at least my case, and then also a little bit about client migration. Now the master client and client migration of the master client could have been its own topic, but I think it's really related to the RPCs because you can specifically send the RPC to the master client, so I think that fits under there. And then I'm going to talk about room settings and why is that useful. You can also have lobby settings, which is kind of similar, but for the lobby. So the structure is you have a lobby, and in that lobby you have rooms. And the room is where the playing happens. And then I'm also going to talk about the Photon components. So the Photon view and the Photon transform view classic. There's like a lot more components that is certainly useful in certain cases. But I thought, at least for my project, those two have been enough. And I'll start with the prerequisites one. Thanks for watching. Okay, so for the first part, I'm gonna talk about the mono behavior PUN and mono behavior PUN callbacks that you can inherit from. Well, according to their API documentation, which you should check out because there's a lot of functionality that I'm not gonna cover, and it's quite useful. Just the mono behavior PUN adds the photon view, so which is actually not something you necessarily need. So this is an empty script, and if I wanted to get a look at the photon view component of this game object, I wouldn't be able to without this. So I can do this, and now I can get the photon view component, and then for example, I could get the ID. Well, alternatively, I could also do this, where I can just say, I can just get the same ID by saying photon view ID. And actually, I think we still need this. Yep, but this works. So basically, a cached reference to the photon view on this game object. This and this are the same thing. And according to their API, there isn't much more about the mono behavior PUN apart from this, which you can just give it a get component. But I guess it's useful. It still inherits from mono behavior, so you can use anything you like the transform and all that. But there's that. But more importantly, what we have is the mono behavior PUN callbacks, and there's a whole list of useful methods, the callbacks that are called by the mono behavior PUN callbacks, and I'm gonna give two examples. One is, for example, I have this create and join room script in that screen where you can add, type a name and join a room. We first, attempt to join a room or create a room, but joining might take some time. And that's why I have this function where I say public override void on joined room. So when the joining room happens, I load my scene, which is where the game is. I could also have this, I commented it out, but it works, where when I leave the room, I just can print out left room. Or if you want to do something else, you can do that here. But the point is, with these PUN callbacks, you always need to do a public override, because a private override won't work, and it has to be an override because there's already these already exist, but you're kind of adding on top of them. And I want to show a second example of the mono behavior PUN callbacks. I'm gonna talk about more of this in the later stages of the video, but basically the master client is really important, because in my game the master client is the one that's locally also storing the map data and also communicating with the room properties. So when I change, if I don't migrate my data, let's say, and the master leaves and then someone else joins, they're gonna be falling to their death because there's gonna be no map because there's no data. So that's why I am making use of this callback, which is on master client switched. And a handy thing, they also pass you a player. A player and a photon view is not the same thing, but a player is responsible for photon view, or could be multiple photon views. But basically, for example, if there's two people in the lobby and I leave, the other player will become the master. So that new master client will be them. And then I just call it, and I notify myself. And if you look at this method here, I can show. What I'm doing is I am sending an RPC, which we'll cover in a bit, to the target player. So to send the RPC, I need to have my photon view component, and then I can send the RPC where I say the name of the script, of the method, excuse me, which is right here, and also I can pass things to it. And actually, yeah, I mean, oddly enough, I actually didn't include this here, but I should have, I guess. Oh my god, I'm so sorry. I thought this was the input, but no, this is the target. So this is the part where you could say things like, I don't know, target dot RPC target dot all. This would send RPC to everyone, but I just want to send it to a specific player, which is the target player. So that's my target. I made a mistake. I'm not passing any parameters. And the RPC, what it does is, to that target player, it calls the room properties and it syncs their map state, which is the local room properties, let's say, and then just it's complete. So when the master client changes, the new master client pulls the data from the edit room, the room properties, so that in case something is needed, someone has it. Otherwise, once the master leaves and the new master doesn't have anything, they would be completely lost. Okay, also I just want to mention as a short note the imports that I'm using. Of course, I'm not using every single capability that they offer, and I'm pretty sure there's those other imports, but for our case, if you want to use the Photon network, for example, to create a room or join a room, you need the photon.pun, because otherwise they're not going to work, as you can see. And then for the real time, this is useful for the player class, I believe. So we can see here, yes, for example, the game goes, what is a player? So you need the real time for player. Also, you need the real time for for example, getting the player list. And I can show that right here. You can get all the players that are active on the scene. This is useful if you want to like name the players, for example, or if you want to store all the players into a scoreboard, and this will be updated when people leave or come back. And this will also require the real time. And the utility scripts, I have so far only have one use, and this is set score, and this actually um, makes the making a scoreboard, keeping track very easy. Even this actually works if I uncomment it. For each player in our player list, I can get their current score, add one to their score, and then print it again, and this will work. And also, the score is actually persistent after you leave a lobby and join back. That's why I use this when they leave room, when they're leaving, which is a button I have on my screen that you can just go back to the join room scene. I just, make it so that when you leave, your score is set to 0. And also change your nickname. This is not with the utility scripts, but the nickname is also another convenient property that each player has. And I can set your nickname. So far, I'm just doing like player 0, player 1, etc. when you spawn in. But in the future, you might make this any kind of name. Maybe let players name themselves. Maybe if your game is up on Steam, plop their Steam name. But you can keep their score and their name on the player, and it's super useful. If they leave and come back, it's going to be persistent. I'm removing it myself, but it can be persistent if you want. And just overall, I think it's really useful. You don't need to use RPCs or anything like that. Okay, now let's talk about RPCs and clients. When you join a new room and you're the first player there, you will be the master client. Well, basically the first person that joins is the master client, but the master client can change. You can change it manually if you want, or when the master client leaves, another one of the clients will become the master client. So that's helpful to know, because you know that there's always one master client. This might be useful because if there is something that you need to keep track of once, you don't want to keep track of it across all the clients, because there might be, I don't know, a dozen players in your lobby. That's just, a waste at that point. And knowing that, when you're sending out RPCs, and RPCs could be sent by any game object that has a photon view component on it. What I mean by that is not just players. For example, in my game, I have a static game object called the bomb manager, where it like manages, what blocks the bombs have destroyed, and where to instantiate the explosion effects, which I'm going to show in a minute. That is also has a photon view component, so that it can send RPCs to everybody else to like update them what's going on in the game. And one different type of RPC is the buffered via server. So I can show you here in this diagram. So in here you can see the master, the target all. You can also send a specific target, like any of those other blue players, if you could just get a reference to them. But there's the buffered via server, or just buffered RPCs also. Just buffered means it's buffered through the client, so if you leave, that won't be buffered anymore. But buffered via server means that buffer will be held in the server, so when someone else joins at a later time, that RPC will be sent to them. Now, you really want to be careful in what cases do you use this, because first of all, you don't want to use RPC. You don't want to use RPCs a lot in general, but buffered RPCs you also want to be hesitant about, because especially if something can change back and forth, say a door opening, right? So a door can be open or closed. You don't want to send the RPC every time you close the door, open it. Well, maybe to the current players you can, but not a buffered one, because the order of the buffered RPC can get messed up after some point. And technically, if we're talking about a door, we only care about the last situation, if the door is open or closed. Another case where it might be useful is, say there's a chest in your game, and when you open the chest, you collect your loot, and it's just an open chest. Now it's useless. Then you might use a buffered RPC, because you can just say, okay, open chest. So when a new player joins, the chest will be already opened, and like there won't be any loot to get from it. Um, Another bad case for buffered RPCs is, for example, my project, because people can constantly place blocks and destroy blocks, and I can't send I used to try that, like sending buffered RPCs, but that goes crazy way too fast, because there might be hundreds of blocks that have been destroyed and created, and then someone joins later. That's just not really useful. So I started using room properties, which I'm going to talk in a minute, but now I want to show some examples of how I use RPCs in my project. Okay, so I first want to quickly show what I am trying to do in the game. So once I show you the code, it makes sense. So we have the two players here now. They can see each other, and I can throw bombs, and there will be explosion effect. Some of the blocks will be gone. In two of the clients, you can see that it's the same thing. What I can also do is I can trigger bombs with other bombs. So this is a large bomb, for example. I can just show you. It's gonna explode in a minute. But what else you can do is you can put a large bomb and then just trigger it with a smaller bomb instantly. But what else you can do is you can put a large bomb with this player and trigger it with this other player, and all the effects and everything will still work in both players, and the same blocks will be destroyed. And finally, there's this launcher that's just used to push. So I can push other players. I can push bombs. It flies away. I can also place a big bomb here and push his bombs too. So those all work. Okay, now that I've shown that, we can get into the code right here. So this is the bomb script. When the explosion is triggered, so this is either when the timer runs out or when they get into contact for some types of bombs. I'm basically getting the position. First of all, I am from my photon view on this bomb, I'm sending out an RPC called trigger effect RPC to every client, and I am also passing in a vector 3, which is the position. It's important to notice you can't pass anything you like through RPCs. You can only pass like more basic components like vectors, integers, booleans, strings. You can search up what you can exactly do, but for example, you can't pass game objects. And if I go to the PUN RPC, it's just like a regular method, but you just gotta add this at the top. And like you see here, I'm passing in the position. It's simply instantiating the explosion effect, and it's like scaling it depending on the type of bomb, and it's making the parent the bomb manager just to keep this scene clean. Like these are not even necessarily needed. But you can see here the bomb is calling that, and then I am, destroying the blocks and all that, and then at the end, I am calling another. I'm gonna call another RPC through the bomb manager this time. I didn't have to do this, by the way. I could have called the RPC from the bomb, but this is how I set it up in the beginning, and it works. So basically, bomb manager is a static game object instance, and I am calling destroy bomb with this bomb's view ID. So if you go here, here it is. So this is a regular method that I'm calling with the view ID, and the method itself calls our view RPC. Calls the RPC, I'm sorry, from the photon view of all the targets. And like I want to show you here, like I said, you can't pass game objects, but you can work around it by passing in a view ID if they have a photon view. And what I'm doing is you can use this neat function which just finds a photon view from the view ID. And then first I'm checking if it's null, like if it's already destroyed or something happened. Just don't do this, like, because it's going to give a null reference exception in the second line, and that is if it's not mine, I return, and then I destroy it. Now what's happening here? You can only destroy. So first of all, when you instantiate a game object that has a photon view component, you need to instantiate it with a with photon network that instantiate. So right here, and the only difference of this method compared to regular instantiate is you pass a name and not the game object. So I can't say, like for example, I can say bomb effects that like this is a game object, but it has to be the name of it, like this. And then you pass the position and the rotation, and whatever game object you're instantiating through the photon network instantiate has to be in a resources folder. So I have just a folder named resources with a capital R, and it's gonna work. But that's not the point. The point is, if you're gonna destroy a game object with a photon view component, you should destroy it with the photon network dot destroy, and it's gonna be synced up with all the clients, etc. It's all good. But then you might be saying, then why the RPC if it's just gonna be synced up anyways? And that's because this destruction can be triggered from something else, but only the owner of the game object can destroy it. So my point is, if I throw out a bomb and then you destroy my bomb, you can't just say photon network that destroy his bomb. I need to be the one that destroying it. So this is why I'm sending out an RPC to all the clients. And so in all the clients, if the bomb is not theirs, they just, end this, nothing happens. But when I am processing this RPC and I'm the owner of the bomb, I'm gonna destroy it with the photon network that destroy. And I also use another I use the RPCs in another method with in connection with the room properties, but I'm gonna cover that after I cover the room properties slightly later in the video. Okay, now I'm gonna talk about the room settings, which is probably the most important part. That has been useful. This has been the most useful component, I believe, in my own project. And I like to think the room settings sort of like the player prefs, if if you have used them before. And it's just like a dictionary where there's a key and a value. The key has to be a string, but the value can be, certain types of objects. Again, this is limited. You can't save like a game object or anything like a component and stuff like that, but you can save strings, integers, booleans, some basic stuff. And you need to also know that you're like there's a limit on how many things you can store. So one thing that I was doing in the beginning was I was trying to store the position, so I have a grid, right? Grid of blocks. I was trying to store each block, each position, whether there was a block or not. And obviously I ran into problems there because my map is like 30 by 30 by 50. So that's like about 4,500 blocks. So you can't save that many different room properties. But I did work around that by passing in multiple positions in sort of chunks that is used in Minecraft. I'm gonna show it in detail in a minute, but that could be useful for you. You could also use other solutions like your own server solutions, but I wanted to use only Photon PUN to keep it simple, and that worked out for me. So let me show you how I worked it. So this is the map generator script, and in here in the start, how I do this is if you're the master client, you're gonna do something else, and if you're not the master client, there's something else. But let's start with the master client. If you are the master client, you're first gonna create the blocks, very similar to how you would in a regular game. I'm literally just looping through my map and I'm creating blocks. I made this like circle pattern. I can do any kind of pattern. It doesn't really matter. But I am instantiating them, and then I'm also storing my map state. So this is a 3D array. There's an X, Y, Z position, and right now, if there's a block at a certain position, it's set to 1, and if there's no block, it's set to 0. But the neat thing is I can use like different integers, right? So in the future, if I have different kinds of blocks, I can just use 2, 3, 4, 5, and I can just have a whole bunch of blocks, and I store them in the map state. And then what I do is I zero the map, which is, I know this is not needed, but I just said it from before. It's basically making sure that everywhere else is a 0 if there's no block. And then I set my PUN room properties. So where is that? Let's check that one. So here what I'm doing is I am getting my current room's custom properties, and it is a its own hash table type of variable, so you just gotta use this, and I'm storing it as properties. So first of all, what I'm doing is I want to store my boundaries for the map. So I am literally getting the map state's upper bound on each dimension, and I'm storing these. And like I said before, the key is a string, and the value can be multiple things, and in this case, an integer. And I'm adding this as a property. One note is you can't add the same thing twice. Like if I do this, it's gonna give an error. Like if I want to change this value and I do this, it's gonna give an error because it's gonna say, oh, a key already exists. In this case, you use a different method, which I'm gonna show. And the case being changing a value as opposed to creating a value. But because this is the first time we're creating them, and here's what I do. So like I said earlier, I can't store each position individually, so what I thought of doing was storing each layer of Y values, sort of imagine like a slices from the bottom to the top. So my map is 30 by 30 by 50. I'm sorry, 30 by 50 by 30. So each Y slice is a 30 by 30 box. So there's going to be 900 values there. So what I do is for each Y value, I create a slice of bytes, and why I'm using a byte is like a integer 8, so it goes between 0 to 255. And why I'm using it is I'm not going to have an integer that's larger than 255, which means I'm not going to have more than 255 types of blocks, but this depends on your needs. I could make it an integer array, but the integer is larger, and you really want to keep these to a minimum because larger values will take longer to pass. Your game will be laggy. It might have been even useful in my case to use some sort of algorithm to like compress this, and I didn't because it works fine for now, but in the future I might use that. You might use some sort of compression algorithm, and you can like research those, and that might be helpful for your case. But basically I'm going through my X and Z now, and for this position in the map state, this is an integer by the way, so I need to cast it to a byte. I am storing it in the slice from 0 to 900, and this is basically I am first going through the Z, so like 1 to 30 is going to be like X equals 0, Z equals 1, Z equals 2, 3, etc. And once I hit the end, I'm going to go back to now X equals 1 and Z equals 0, and this is basically finding the correct position for me. And once this whole loop is done, so my slice is complete, I add the slice as a property, and the name of the slice is the Y value as a string. So I don't know, this might be 3 or I don't know, 29, things like that. It's just a string of the Y value. And then once I'm done with the whole looping and I'm done with all my properties, I need to save those properties back. So I get the properties and I said set custom properties, and then I just pass on the properties that I changed, and I say data is set. So now the data is set. When someone else joins back at the start, I'm saying, okay, I'm not the master client, I'm gonna get the data. I again get the data the same way, and this time I'm not gonna set the data, but I'm just gonna get the data. So I'm again very similarly looping through my whole map, and I'm saying the slice is the properties of Y to string. So if you want to get the property, you're just gonna need to do this. You're just gonna go, I don't know, your key name. And in that case, it's the Y to string, same thing I did earlier. And I'm casting it into an integer byte because it's an object when you get it actually. So your property might be integer, right? In that case, you need to cast it to an integer because they're all passed as objects, which is not very useful. And I'm getting it as a slice, and then very similarly, this was just my fail safe because so far I'm not gonna have any block that's not a type of 1. So I'm not gonna do it if it's not a 1. But if it's not a 1, and if it's not bigger, so bigger than 1 is a bug. So I don't know, it's an error. If it's not 1, it means it's a 0. 0 means no block, so I'm not gonna do anything. But if that's not the case either, aka it is a 1, then I'm gonna instantiate my block. Okay, and then this is the force field, which is basically the large red object in the bottom. When the player falls, they die, and that's nothing to do with the properties. But this is how I do this. So now finally I want to talk about editing the room properties, which is gonna be right here. Edit map state. Okay, so how does this work? So when a block is destroyed, okay, just a heads up, this is probably not the most efficient way, but this works for me, so it's how it is. Excuse me. When a block is destroyed by a bomb, I pass its position, and the bomb calls this method. Okay, we can we can see it right here actually. As you can see, it's destroy block. It calls that, and then there's a RPC sent. Basically, I'm trying to find if the block is there. If the block is there, I found it, and if it's not there, I'm not gonna do anything. If I find it, I am gonna play the effect of the block destruction. I'm gonna destroy the block. As you can see, there is no like is mine thing here because the blocks don't have photon views. Like the block is there on every client, and I want to destroy it on every client. No questions asked. I instantiate my effect, I destroy my block, and I edit my map state. So as you remember, the map state is the local one. So if you go to the edit map state here, this one is only sent to the master client as RPC because only the master client is keeping that state data. And again, I'm passing the new state that I want to give it and the position. And these are the type of variables that you can pass. And here, this will only go to the master client, and in the master client, I'm gonna, get that map state position, and I'm gonna set it to the state. So this map state is being updated. I'm gonna show a diagram of this about in a minute, by the way, and it's gonna make things more clear in my opinion. But the final piece of this puzzle is when master client changes, because like I said, the map state is only stored in the master. So what happens if the master leaves? Well, in that case, we need the handy PUN callback. So this is inheriting the PUN callbacks, allows me to use this useful thing right here. Wait, here, right? So on master client switch, this is very useful. It even tells you what player is the new master client, and in that case, I'm setting the map state to the new master client. So basically, what I'm doing is I am telling the game, hey, the master client is changing. We're gonna lose the map state. We're gonna lose that data. So we need to pass it. So what happens is, because it's already there in the properties, the new master client is gonna pick that properties up and it's gonna store it in its own map state. And again, I am only sending this RPC to the target player. So this is like, target all or target master client. You can also just pass a target that and I'm doing that. Target is a player. This is a Photon construct, and I'm just gonna save the map state here, and I'm gonna say the map state is complete. So this way, let me just quickly show you what happens in game. So I'm in a game right now, fresh lobby, 2 players. This second client on the right created the lobby, and first of all, I can leave and then rejoin, and it's still here, same lobby, right? And we can even destroy some blocks and then leave and then rejoin, and the same blocks are still destroyed, so it's still synced up. And now the fancy thing, this is the master. I'm gonna leave as the master. Actually, we should get a on client switched. Yeah, set map state complete, so the client did switch. So now this is the master client, and if I join back again, same room, and let me just fly, and the same blocks are still destroyed. So the master client switched. Now the left is the master client, and it's still synced up. So I can just destroy some blocks here, some more, and I can leave and enter room again. And if we go up there, it's gonna be still synced up. So this works, pretty neatly with no problems. This is what I'm talking about when I'm, mentioning the room properties. In the beginning, the master can edit the data, the room properties, and every other client gets the data from the room properties, okay? But in the later stages, this is how things work basically. So first, the regular client does something locally, right? Destroy a block. That goes to the map generator. There's a PUN RPC sent, telling every other client to destroy the blocks, right? But we also want to be able to keep this map synced up for future players. So the map generator sends another RPC to the master client to update the room data, and this master updates this map state, the local one, and it syncs up the room properties. You might set it to every X seconds. In my case, what I'm doing is I'm syncing it when the master migrates, when a new player joins, or when something happens, like a block destruction happens. I'm syncing them, so when a new client joins, they can just get the room properties, which is going to be the up-to-date, synced map with the correct blocks destroyed, etc. And this is the, general structure of how it works. Finally, I want to talk about the Photon components, and there's a whole bunch of them. And you might be using different ones for your needs, but I am basically using 2 of them here. Oh, actually I have this disabled. So this is if you want to sync up animations, but I don't have any animations yet. So first one is the Photon view. We talked about this a lot. It's how you send RPCs, get data, send data, all that good stuff. And the other one that I use commonly is the Photon transform view classic. So it's basically to sync up the position of an object between other clients. And there's a lot of options here. You might want to scale, you might want to synchronize the scale or not, or the rotation, or the position. I want to sync all of them. And the other thing is there's the intraplate and extraplate options. So this is because there might be lags, right? There might be some lags. There might be some, the client is maybe waiting to get data. You don't want to have your game feel jittery. So in that case, the game gives you options to, change the position or the rotation as if you know what's going to happen. And this is kind of useful if you have, like, let's say bullets or bombs where, like, okay, my bombs can like bounce off of walls, etc., but it's still they're going to follow the same trajectory usually in the air. So it might be useful to just, extrapolate with the fixed speed. I'm just like synchronizing the values, and I don't want to extrapolate. I'm just using the interpolate. But as you can see, there's a whole lot other, types of photon components that might be useful for your case. And I hope this video has been helpful for you. I know there's a lot of things going on in Photon, and I honestly don't know everything either, but this has been good enough for me to get going and start building my project, and I think it will be helpful for you too. And if you have any questions, please ask them in the comments, and thanks for watching.